to describe some of their attributes, like where they're increasing, where the function's decreasing. And if we have some time, we can hit some skills with rational functions, because we know that's just a quotient of two polynomials. So I've created some examples for us. And each slide that you see in the PowerPoint is going to correspond to the question number. So this is a little hard to read, but it'll be better in just a minute. Number 3 on the exam sheet is a question about domain. Look at the graph and determine the domain. And it's got this square root function here. Yeah, it'll be better. It'll be easier to see in just a minute. Number 5 is a average rate of change problem. So when we go to slide 5 on the PowerPoint, it'll be an average rate of change problem. And I've uploaded the PowerPoint into D2L. And it just has a whole nother set of questions. So you have another 100 questions eventually that you could look over if you need to. Scroll through all 100 slides, I can go straight to slide 3. Let's see if that works. Okay. So let me know if I need to zoom in or whatnot. But question number 3. Use the graph to determine the function's domain, and then use the graph to determine the function's range. Write down the domain of the graph in interval notation. Write down the range of the graph in interval notation. I'll give you a second to think about that. The x-axis is scaled by 1 unit, so we go from 0 to 1 to 2. The y-axis is scaled in tenths. We go up to 2 tenths, 4 tenths, 6 tenths, 8 tenths. Up to 1. So domain and range. So we'll check your answer. We know the domain is the x values for which the function is defined. We only have a semicircle. And it looks like only for the x values between -2 and 2 do we have an output. So what would be the interval notation for that set of x? I heard the -2 to 2. Which kind of bracket? The square one? Yeah. Closed bracket or the square one, indeed. All right.
You know it's the square bracket.
Well, because I don't see an open circle that's emphasizing to the reader that I should exclude it. So I'm assuming there's an ordered pair there. It's not emphasized.
If it wasn't emphasized, then it would be parentheses.
If it was emphasized as open, then it would be parentheses. Yeah. So that's going to be the same for the range. They didn't emphasize it, but we assume there's an ordered pair with output 0. And what's the highest output? So just from what we can see, the range is from 0 to 1. Range is the y values. But we could simply write that as an interval. And again, we'd include that. So typically we'll use this open circle to remind the student that we're not using that input or output. So that was a graphic example. Moving to slide 6. Now we'll have to do a little algebra. of x is 5 times the square root all over this product. I'll give you a moment to think about the domain. Summarize this in a minute. But when we look at a function, 1, if it has a quotient, if it has a denominator, we don't want to divide by 0. So 1, we're going to exclude values of x that make the denominator 0. And 2, we don't want to end up taking a square root or an even root of a negative expression. Otherwise, we'll get an imaginary answer. So the domain of the function is typically going to be all real numbers that satisfy certain properties. We don't want the denominator to be 0, and we don't want the number under the radical to be negative. So we do some scratch work. Let's figure out when the denominator is 0. Did you set this product equal to 0? And then solve? And if a product is 0, that implies one of the factors has to be 0. What 2 values of x should we exclude? Yeah. We exclude negative 2. We don't want that. And we exclude the 3. We don't want that. So our domain of f is all real numbers such that x doesn't equal negative 2, nor does it equal 3. Hey, Mary, do you mind sitting right here in front of Daniel today? Yeah. Or Allie, she'll move you. One technician. Okay. Now we haven't, in my class, we haven't talked about this in a little while. There's a radical in the numerator. It's an understood index 2. It's a square root. So this expression, x plus 7, we need it to be greater than or equal to 0. If it's not, we'll get an imaginary answer. So step 2, solve this inequality. So we can simply isolate x, subtract 7 from both sides. Subtracting or adding does not change the inequality. And so our domain only includes numbers where x is greater than or equal to negative 7. So we have 3 conditions on our domain. Do I need to clarify anything there? Let's see if we can write down the same answer in interval notation. Suggestion. Shade in a number line to satisfy property 2, and then go back and exclude anything from property 1. So we can shade in the numbers greater than or equal to negative 7. Which direction on the number line is the greater than direction? Thank you, that way, okay. So we've already restricted ourselves to the shaded set. And now we have some further restrictions. X cannot be negative 2. Is that in the shaded area? Actually, like maybe 0 is over here. And so negative 2 is actually, okay. So we'll open it up at negative 2. and we'll estimate where 3 is, and we open that up. And so we're only going to include real numbers between -7 and -2, -2 and 3, and anything bigger than 3. 1, 2, 3 shaded intervals. Can you write down 1, 2, 3 intervals connected by 2 union symbols? It's actually the half open interval, -7 up to -2. But we've emphasized that we're not including -2. We have the open interval from -2 up to +3. And then anything bigger than 3. This would be a more formal answer. Yeah? Yeah, it would. So the question is, could we write these intervals with greater than or equal to symbols? Yeah. We would have a double inequality here, or this double inequality, or this inequality. So if you think about it, we want x between -7 and -2, or x strictly between -2 and 3, or x greater than 3. You can do it, it may not be pretty. Feel free to stop me if you have a question. So here's one for you now. I'll give you a rational expression. See if you can write down the domain either in words or as an interval so that you can recognize the domain on multiple choice. Slide 12. Find the domain of R if R is -x over the product 3 times the square root of x plus 7. Quotient, we don't want the denominator to be 0. Scratch work, set the denominator equal to 0 and solve. Divide both sides by 3. Now solving for x, how do we undo a square root? Square both sides. Okay, so squaring the radical left with the sum, and 0 squared? Ah, okay. -7 would make the denominator 0, and we don't want that. And then this expression underneath the radical, we want it to be big enough so that we don't get a negative number. So you just take the expression that's under the radical, no matter what it is, and set it greater than or equal to 0. Now one detail here, we don't want it to be 0 at all, because it's in the denominator. So we can go ahead and exclude that possibility. already excluded that here. We just need to make sure x is strictly greater than -7. So we don't want x to be -7 at all. In fact, we want x to be strictly greater than -7. So open interval -7 to infinity. That ended up being easier. Maybe a timeout to summarize some things about domain. Anytime that you can categorize functions and make some generalizations, that helps you come up with strategies for analyzing them later. There's several categories of functions whose domain is all real numbers. There's several. Their domain can be all real numbers because there's no division by 0. Right, that would be bad. Division by 0 is bad. They don't have any radicals in them, so you're not taking square root of a negative number. So all polynomials are defined for all real numbers. Exponentials, like e to the x. There's no division, no radicals. In fact, any exponential base a to the x. Sine and cosine are defined for all real numbers. So they're the easiest to analyze because they're defined everywhere. Polynomials of every degree, exponentials of any base, and then the two basic trig functions, sine and cosine. When you see them, the domain is all real numbers. On the other hand, we may find the rational function that we're looking at, kind of like we've been seeing, where you have a polynomial over a polynomial, and then you want to set the denominator equal to 0 and exclude the values of x that make the denominator 0. And that's your strategy. Third category, if the function has an even root in it, if it has a square root or a fourth root or any index here that's even, then you look at the expression that's under that radical and you say, hey, that expression has to be greater than or equal to 0, and you solve the inequality. And you keep those. You want the expression to be positive, so you keep those. You don't want a denominator to be 0, so you exclude those. Question. Can we take an odd root of a negative number? And is that defined? Is there any number times itself 3 times that would give you -27? So it'd have to have a 3 in it. 3 cubed is positive 27. Can I make them all negative? Yeah, positive times a positive, or negative negative makes a positive product. Times a negative is negative. Ah, okay. So back in the first category, functions that are defined for all real numbers, you can also put in odd roots. They pose us no problem. But even roots we have to be careful with, like we were careful here. Okay. These are only 2 of our trig functions. In what category might tangent be listed under. Is tangent defined for all real numbers? When you think of tangent of x, how do you rewrite it? Say that again.
Can equal 0.
We have to be careful with zeros. But tangent can equal 0.
I mean, it can't. If it does, it's undefined.
So give me a way of rewriting tangent. Okay. All right. Okay, so tangent can be thought of as a quotient, and we don't want the denominator to be 0. So I would put tangent in the quotient category, because you don't want the denominator to be 0. Cotangent, secant. What's the other one? Cosecant. I would put them in that category because you've got to look and see when the denominator is 0 and exclude those values of theta. And just quickly, this other category is kind of a catch-all. Logarithms work a little bit differently than all three. Just a reminder, if you have logarithm applied to any expression, that expression has to be strictly positive. The expression has to be strictly positive. Log is not defined for 0, and logarithms are not defined for negatives. So I'm going to put that in a separate category. Well, I'll save that discussion for logarithms the next hour, because I promised at the 9 o'clock class we would do logarithms. Any questions on domain right now? We're about to switch over to average rate of change. Yeah, that's all.
What did you do with negative x? The numerator.
Okay. So the domain is all real numbers for which the quotient's defined. And the only time we would have a problem is if the denominator was 0. Okay. For example, r of negative 7 would be the opposite of negative 7 over 3 times radical of negative 7 plus 7. And we get 7 over 3 times 0. And that's going to give us an error on the calculator. R isn't defined at 7, so we have to write undefined. But R of 0 is okay. Opposite of 0 is just 0. And when I plug in 0 here, we get 3 times radical 7. And 0 over a non-zero number just simplifies to 0. This function goes through the origin. We don't have to worry about the numerator. That would be an x-intercept, but it's not a worry. Okay. I'll tell you what. Here's a good segue. Slide number 1. Let's see if you can tell enough about it. Slide asks you to write the equation of the line, and just to clarify, its x-intercept is negative 4, and its y-intercept is negative 1. Negative 4, negative 1. Can you write the equation of that line? Some old stuff back in it. I'm going to overemphasize the intercepts. And as an exercise, I'm going to What's the ordered pair for the x-intercept? Yes, thank you. -4, 0. And the ordered pair for the y-intercept? Yeah, x is 0, y is -1. Could someone tell me a formula for finding the slope of a line? So I heard you say y2 minus y1 over x of 2 minus x of 1. And what's an everyday way of describing that? You're in a physics class and you're talking about slope. How do you describe slope?
Average rate.
It is average rate of change. Ooh, and or velocity. What else? It'll help us compute distance. But it's the distance between the y values over the distance in the x values. I guess I was looking for change in y over change in x. The everyday words and the symbols. So let's calculate the slope of our line. It's descending from left to right. It's falling from left to right. What should the sign of our slope end up being? Negative. Okay. So we got change in y, -1 minus 0, over change in x. 0 take away -4. What is our slope? -1 over +4. Indeed. Well, to write the equation of a line, we need a slope, and we need any of the points on the line itself. We have the y-intercept. If you haven't, go ahead and write the y-intercept form of this line. A lot of textbooks would label that y equals mx plus b. I want to emphasize something here. That number b is very specific. It always refers to the y-intercept 0b, and so we have to assume, we have to label b as -1 in this case. So, final answer, -1/4 x minus 1. That's the correct answer there. But we're preparing ourselves for our next course. And in calculus, we aren't always given